Hi, welcome to ML Insider. My name is Kurniadi, and I'll be sharing with you my research topic on deep video analytics. Video are one of the most interesting data types, being a series of images. What makes video more interesting in deep learning field is the abundance of data in our digital era. Think about it. Video uploading platforms like YouTube, TikTok, and Instagram are uploading 300 of terabytes of user video stream every day. It's really that much data that we can explore and exploit to empower our AI. So I'll be sharing with you what are the video analytics and video processing, and I'll be showing you how deep learning can be incorporated to learn from the content from video to empower our AI. So some questions probably why video datasets modality, and what is the difference between video image algorithms in machine learning? What's the difference between them? And what are the applications of video analytics that we can use to leverage our technology? Right, so video modality, in terms of availability and abundance, we have enormous video storage from the video uploading platform and social media. And in addition to that, our video cameras are basically everywhere. Think about it. We have mobile devices, we have phone and tablets. They have cameras on their own. And video camera surveillance are everywhere, mounted in a big city. For example, in China, we have 300,000 surveillance camera. And video is also rich in semantic information. We can learn a lot from video. For example, we can learn on human action and motion. We can leverage on our object motion and object tracking. And finally, there is several models that benefit from video. For example, object detection model and object semantics model. So first, let me go through with you what's the difference between video and image in machine learning algorithms. First is video are just a bunch or stacks of images, right? Well, yes and no. Video frames that are adjacent turns out to have additional information more than just a stack of images. Those information are often called temporal correlation between one and the other frames that are adjacent, right? So there are a flow of information, not just appearance from one frame to the next frame in the video. Next, does image algorithm then still works well on video? Say, if we can apply image algorithm one by one for each frames. Well, yes, certainly, but there is a catch. Of course, we are going to discuss later how utilizing video based algorithm can benefit for learning the content in the video itself. And then the third, what are the difference between processing algorithm between these two modalities, right? So let me reiterate again that there is the difference between algorithm for these two modalities are that in image you are only exploiting or learning the special feature of whatever appear in your image. For example, you learn about the objects or the shapes or the contour in that image. But in video, you'll also learn the progression of one frame to another. And this progression can be, for example, motion information from one to the other frame that we can learn, for example, to understand human action or to understand the content of the video better. So now let us dive into the application of deep learning in video analytics. There are many applications of it. One is being situational awareness analytics. This is where in cameras like in big city, you can have a video that learns and can detect if there is any aggression, if there is any criminal action detected in the CCTV surveillance. And then next, you can also employ deep learning models for object detection and tracking in video-based data. For example, from the camera that is mounted in the AV car, for example, or from the camera in traffic CCTV surveillance. And then you can also learn and deploy deep learnings for video in painting. Let's say, for example, you can segment the background of a video and turn it into, or maybe clean a person out of that background, for example. So that's video in painting. So that are some of many applications of video analytics using deep learning. Of course, in computer vision itself, many algorithms are still specific for images, and video itself are still a largely unexplored domain. Now, let me share with you regarding my research. So my research are revolving around these two topics, which is human action recognition and deep video denoising. So first, about human action recognition. What are human action recognition? Human action recognition are challenging computer vision tasks in understanding the action happening in the video. Although it's widely used, accurate and efficient human action recognition remains challenging. The focus of my works revolved on action feature representation using deep learning. So the main of these works can be summarized into two, which is the two-stream COVNET methods and the 3D based video action recognition. So first, the two-stream COVNETs utilize optical flow and RGB images, and it has two-stream COVNET, which eventually learn the feature representation from these two modalities separately. And in the end, usually a two-stream COVNET will have a fusion module that will fuse this feature into a prediction. So that's two-stream COVNET. The first two-stream COVNET is proposed by Karen Simonian and Andrew Zizerman. And the improvement of the two-stream COVNET are proposed by Li Min Wang in his paper of temporal segment network. So the concept here is that video does not always contain the action, because some action are only contained in some parts, let's say in the middle of the video. So the idea here is extending the two-stream COVNET such that we can just segment the video into different parts, and then we can also do consensus not only for different modalities but also for the segments. So the segment of video that contain the action will have the more weightage to the output of the video. So that is temporal segment network. Another approach of human action recognition is using a 3D convolution net architectures. One is proposed by Andrew Zizerman again on the Quo-Vadis action recognition paper. So the idea here of 3D convolution is that it's not only convolving on the spatial domain, which learn the appearance in the video, but it will also learn the temporal features. So it will convolve along the temporal, and it will eventually able to learn naturally the motion evolution from one frame to another. So that's the idea of 3D convolution net. Another interesting methods uses pose, human pose estimation, so that you can also the model can also learn from the skeleton or the pose that a human made when they are doing action. Let's say, for example, if you're standing or walking, you have several key points and pose configuration. But when you are doing, let's say, fighting, or let's say you're punching, your hands would create different pose than if you're just standing. So the idea there can be used for predicting action. And then finally, the second part of my research also revolved around video denoising. Video denoising is becoming really necessary because high-level computer vision algorithms are sensitive to small perturbation or noise. Traditional denoising algorithms, being a low-pass filter, introduce unintended blurring, while at the same time, image denoising can be extended to video denoising by learning temporal correlation between two adjacent frames. Now, the idea of my video denoising is that I'm using a segmentation module, a unit, to actually learn the residual from the noisy image. So this residual is learned to identify which part in the video are noise, and then with that, after the model learns which part is noise, we can actually subtract the predicted noise to the noisy image and hence become a clean image. So that's the rough idea of deep video denoising. So with that, it will end my presentation and research sharing, and thank you for coming to Emily Insider.